Shake Table Lab by Sky Shia and Jonathan Nachman. My partner and I had made a building sketch. We made our building sketch on Sketch. Our design was made based off of what the building requirements are and how many straws we get. The design is planned to have the bottom story 21 centimeters and the top story 18 centimeters, which didn't end up happening, nor did the main shape. For the first step of the building project was to tape down the main perimeter of straws on the cardboard. Our group did our base all the way around the board because we thought that would distribute the weight better. The second step was to build the frame of the first story, which is required to be at least 18 centimeters. We planned for our first story to be 21 centimeters, but it turned out to be 21.5. A building code later came in that our towers had to be bolted in the base, so we did that by drilling 4 holes in the base and putting a straw on all 4 sides, then folding them under and taping them. To do the third step, my partner and I completed the first story and did the frame of the second story. We knew that triangles were the strongest shape made by straws to support the tower. So on the bottom story of our tower, we made each of the 4 sides have a cross out of straws. Then we put 2 little straws in each of the 4, creating triangles. We ended up not doing our calculations right, and on the bottom story, we used well over the majority of straws, not planning so much for the top story, but our bottom story was very strong. The last step that we did of building our tower was the top story and the unique design on top. Our top story was planned to be 18 centimeters and turned out to be 20 centimeters. But for the top story, we did not have many straws left, so we used 2 straws on each side, making a triangle. That was pretty strong, but not nearly as strong as our bottom story. Later on in the project, we have received a message saying that all of our towers looked the same, so we needed to build a roof that was unique. So we made a spot for the sandbags up a little bit, making a slant roof with the flag on top of it. The dimensions on our tower are relatively close to what we planned. Our whole tower is 80 centimeters tall. Our first story is 21 centimeters tall, and our second story is 19 centimeters tall. The tower we had made was static tested, to see where the errors are. Static testing is when your building has only a few weight packages on it while staying still. When Sky and I static tested, we did a little amount of weight because if you do just a little too much, your tower can bend and never be as strong again. So we only did 2 weights a story. With 2 weights a story, our building didn't show any signs of weaknesses. The strongest parts of my towers are color-coded. The same color is the same main design, but the other side. On my group's tower, the green is super strong. It is where all of the multiple triangles meet on the bottom story. The orange is where it's 3 straws combined to make 1 post as the supports. And the red is where the triangles are made to support the second story. What ended up being the really strong parts on our tower is the green pointing to where all 4 triangles meet. Triangles are the strongest shape for holding towers upright. Also, we tripled our straws on the 4 foundation corners of our tower. The weakest parts on our tower are where we didn't put enough supports to withstand the shaking. Something that I think is weaker than the rest is the green first story actual floor, because it is going to be holding up half of the weight and only has a few straws holding it up. Also, second thing that I think is weaker than the rest is the red second story actual floor. As well, the second story is weak for the same reasons as the first floor. And lastly, I think our orange beams on all 4 sides is weak because it's holding a lot with only 1 straw aside. Our tower had a couple nests of tape, but the main ones are the ones pointed to with the arrows. First is where the green arrows are, where the 4 triangles are being connected in the center. And second is where the red arrows are, where the first story connects to the 4 posts. The extra supplies we got for our tower is a sheet of blue construction paper for the first story, and a sheet of black construction paper for the second story. Also, we got extra straws to make a roof that is unique. To make our roof unique, we used a sheet of white, red, and blue construction paper as well. The video here shows our tower successfully surviving with only a few sandbags on it. Mr. C it does, but apparently he takes his word back, guys. I'm scared.
Oh, that top hole.
He's giving us a major earthquake at the beginning. This is our tower failing while being shaken with 21 sandbags on it. A sensor is placed on your tower to measure the movements of the tower. The graph that you get at the end is called an XYZ graph. The X is the side-to-side movements, the Y is the forward and backwards, and the Z is up and down motion.
Hi, my name is Skyshop. Today I'll be talking to you about the tower that my partner and I built for our Shake Table Lab. Our tower held 21 sandbags before collapsing, or actually 19, but it collapsed on 21, so we got a count of 19. And our building failed. Well, it failed first on the top story because the triangle patterns were pretty weak compared to our first story. And then Mr. C let us pile all the sandbags on the first story, so it would count for the second story that failed. And and to make our tower better, I think we could, if we could use less straws for the bottom story and more straws on the top story, then we'd probably make everything stronger, and it would be stronger overall. And then I think it'd survive longer. And I learned that from building an earthquake tower, an earthquake-proof tower, that bolts are really important for our tower because they kept the tower in place when I was about to fall. And what I liked about the tower project is we were always building, and we could test it with static tests and sandbags, and yeah.
Hi, my name is Jonathan Knockman. The tower my partner and I built held 19 sandbags. It collapsed with 21 sandbags on it. Our tower first collapsed at the top story because the triangle patterns broke. When all the sandbags were moved to the bottom story, the V pattern gave out after a couple of shakes, and so it got 19 sandbags. Overall, I think we could have made our tower stronger if we were to use less straws on the bottom story and more straws on the top story. I think it would have distributed the strength overall through the tower better. I learned that one of the most important things in the tower is the bolts because it really helps keep the tower down when it's being shooken a ton. My favorite part of the project was to make the design and actually build it with my partner because it was really cool to see what the design being built.